Let's look at the basic steps to draw a simple Lewis structure. The first step is always to do the inventory to determine how many valence electrons are present in that compound. So for nitrogen trichloride, I make a column of the elements present, nitrogen and chlorine. I make a column that shows how many of each element is present in the compound. There's one nitrogen, there's three chlorines. I then make a column of how many valence electrons each element contributes. Each nitrogen contributes 5, each chlorine contributes 7. I then multiply across to get 5 and 21, and then add those two numbers together to get a total of 26. Just be careful if it's a polyatomic ion, you need to factor in that charge to the inventory. Always do the opposite of the charge. So for example, for hydronium, we have 9 valence electrons when I did that basic inventory, but I needed to make sure to subtract 1 to get a total of 8. So if there's a polyatomic ion, you factor in the charge, do the opposite of whatever the charge is to the total valence electron count. You then need to identify what the central atom is. It's generally going to be the first element in the formula. So for NCl3, nitrogen is the first thing in the formula, so it's going to be the central atom. The only exception is hydrogen. It can't be the central atom. So if hydrogen is the first thing in the formula, just use the second thing in the formula as the central atom. So since hydrogen can't be the central atom in this one, oxygen is going to be the central atom instead. Your next step is you need to go through and place the other elements around the central atom. So in NCl3, there's 3 chlorines. So I put those 3 chlorines around nitrogen. I'm connecting each outer element to the central one with a single covalent bond. That's going to use up 2 electrons for each bond that's formed. So I used 6 electrons in creating those 3 bonds. Same thing for hydronium. Oxygen is the central one. I'm placing the other elements around it. There's 3 hydrogens. I connect each hydrogen to that central atom with a single bond. That used up a total of 6 valence electrons. So just make sure as you're adding stuff into the Lewis structure, you're subtracting from your inventory. The next step is going to be to fill the shells of the outer elements. So say for example, I have chlorine and it's an outer element. At this point it would have 2 valence electrons. I want to try to bring it up to having a total of 8, so I'm going to add 3 non-bonding pairs to it. That's going to make it have 8 valence electrons, and it's going to follow the octet rule. What you have to be careful of is when you're dealing with hydrogen, once it makes a single bond, it's happy, it's done because it has 2 valence electrons. What you don't want to do if hydrogen's an outer atom, you don't want to place non-bonding pairs on it, you don't want to place any dots on it, you don't want to form double or triple bonds. Once it makes a single bond, it's happy, so you don't fill the shells of hydrogens if they are the outer elements. Then if you have any electrons remaining, you're going to place them on the central atom as non-bonding pairs. So at this point for NCl3, I would have 2 electrons remaining. I would place them on that central atom as a non-bonding pair. Just make sure to give them their own real estate on that central atom. Same thing for H3O+. I would have 2 electrons left over at this point. Since I couldn't place any of those dots on hydrogen, they're filled, I would place it as a non-bonding pair on that central atom. Your last step is once you have 0 electrons left over in your inventory, you need to stop and check that central atom. You want to make sure that it has an octet. So for example, in NCl3 nitrogen trichloride, that nitrogen has 2, 4, 6, 8 valence electrons. It's following the octet rule. I know that I can stop. I don't need to do anything else to the structure. The other thing I recommend is checking to see how many bonding and non-bonding pairs you have. So I have a total of 3 bonding pairs and 10 non-bonding pairs. I add those 2 numbers up together to get a total of 13. I multiply that by 2 because each of those things represents 2 electrons. That gives me a total of 26 electrons. That's how many I wanted in NCl3, so that lets me know that the structure makes sense. So same thing for H3O+. I check oxygen. That central atom has a total of 8 valence electrons. It's following the octet rule. I can then check to make sure I have the correct total number of electrons in the structure. There's 3 bonding pairs, 1 non-bonding pair. 3 plus 1 gives me 4, times 2 gives me 8. It has how many electrons that hydronium should have. My first step is to calculate the total number of valence electrons. So there's silicon and fluorine, there's 1 silicon, there's 4 fluorines. Each silicon is going to contribute 4 valence electrons, whereas each fluorine would contribute 7. I multiply across and I add to get a total of 32. My next step is to identify the central atom. So the central atom is generally the first element in the formula. The exception is hydrogen cannot be the central atom. You would move over to the second element. So silicon's my central atom. I'm now going to place the other outer atoms around that central one. So I have 4 fluorines. I'm going to connect each fluorine to the central atom with a single covalent bond. That uses up 8 valence electrons total, and now I have 24 left over. Now I'm going to go through and fill the outer shells of the outer elements. So as I'm filling them, I'm subtracting. As I'm filling them, I'm subtracting. And now I filled all of the shells of the outer elements, and now I've used up all of my valence electrons. So when I check that central atom, silicon, it follows the octet rule because it has 8 valence electrons, so I'm done. There's a total of 12 non-bonding pairs and 4 bonding pairs in this structure. When I add those two numbers together, 12 plus 4 gives me 16. 16 times 2 gives me 32. It matches how many valence electrons I needed in the Lewis structure. To solve the Lewis structure for H2O, my first step is going to be to figure out the inventory of valence electrons. There's hydrogen and oxygen. There's 2 hydrogens and 1 oxygen. Each hydrogen contributes 1 valence electron. Each oxygen would contribute 6. I multiply across and then add. There's 8 valence electrons total for H2O. I figure out the central atom. Hydrogen cannot be the central atom, so I go to the next element in line, which is going to be oxygen. I place the 2 hydrogens around oxygen, and I connect each hydrogen to that central atom with a single bond. That uses up 4 of my valence electrons, so now I have 4 left over at this point. My next step would normally be to fill the shells of the outer elements. But since hydrogen is happy with 2 valence electrons, and each of those hydrogens has a single bond, I'm not going to add anything more to the hydrogens. Instead, what I'm going to do is I'm going to place those 4 remaining electrons on the central atom as non-bonding pairs. So I'm going to place 2 non-bonding pairs on oxygen. I now have used up all of my valence electrons, so now I'm going to check the central atom. Oxygen has 8 valence electrons. It's following the octet rule, so this Lewis structure is done. There's 2 non-bonding pairs and 2 bonding pairs. 2 plus 2 gives me 4, times 2 gives me 8. It matches how many valence electrons I needed to place in the Lewis structure for H2O. Alright, so my first step to solve the Lewis structure for CH4 is to figure out how many valence electrons are present. There's carbon and hydrogen. There's 1 carbon, there's 4 hydrogens. Each carbon contributes 4 valence electrons, whereas each hydrogen would contribute 1. I multiply across, I add to get a total of 8 valence electrons. I figure out that the central atom is carbon. I place the other elements around that central atom. I connect each outer atom to the central atom with a single bond. That uses up 8 valence electrons, so I have 0 left over at this point. When I check that central atom, carbon, it has 8 valence electrons, so it's happy, so I stop. There's a total of 0 non-bonding pairs and 4 bonding pairs. 0 plus 4 gives me 4, times 2 gives me 8. That's how many valence electrons I needed in the Lewis structure for CH4. My first step is to calculate the total number of valence electrons. So there's nitrogen and fluorine, there's 1 nitrogen, there's 3 fluorines. Each nitrogen contributes 5 valence electrons, each fluorine contributes 7. I multiply across and add to get a total of 26. Nitrogen is going to be the central atom. I place the 3 fluorines around it. I connect each fluorine to the nitrogen with a single covalent bond. That uses up 6 valence electrons total, so now I have 20 left over. Now I'm going to start to fill the shells of the outer elements by placing 3 non-bonding pairs on each one. So as I'm adding those non-bonding pairs on each outer atom, I'm subtracting, and that's a key thing. You want to make sure you're keeping a good track of how many valence electrons you're using up. So at this point, I filled the shells of all of the outer elements, and now I have 2 electrons left over. I'm going to place those 2 remaining electrons as a non-bonding pair on that central atom, and now I've reached 0. So now that I've reached 0, I check the central atom. Nitrogen has 8 valence electrons total, therefore this Lewis structure is done. There's a total of 10 non-bonding pairs and 3 bonding pairs. 10 plus 3 gives me a total of 13. 13 times 2 gives me 26. It matches how many valence electrons I needed to place in the Lewis structure for this compound. My first step is to determine the total number of valence electrons. There's carbon and chlorine. There's 1 carbon, there's 4 chlorines. Each carbon contributes 4 valence electrons. Each chlorine contributes 7. I multiply across and add to get a total of 32. I figure out the central atom, which is going to be carbon. I place the 4 chlorines around carbon. I connect each chlorine to carbon with a single bond. That uses up 8 electrons, and I have 24 left over at this point. Now I'm going to fill the shells of the outer elements. As I'm filling each shell, I'm subtracting and keeping track of my inventory. When I've finished filling all of the shells, I have 0 electrons left over. When I check that central atom, carbon, it has 8 valence electrons, so this structure is done. There's a total of 12 non-bonding pairs, 4 bonding pairs. 12 plus 4 gives me 16, times 2 gives me 32. That matches how many valence electrons I needed in the Lewis structure. First step is going to be to calculate the total number of valence electrons. There's sulfur and oxygen. There's 1 sulfur, 4 oxygens. Each sulfur contributes 6 valence electrons. Each oxygen contributes 6. I multiply across to get a total of 30. What I have to be careful of is I have to factor in the charge for this polyatomic ion. I do the opposite of whatever the charge is, so I'm going to add 2. So my total number of valence electrons for sulfate is going to be 32. I figure out the central atom, which is sulfur. I place the 4 oxygens around it. I connect each oxygen to sulfur with a single bond. That uses up 8 valence electrons. I now go through and fill the shells of the outer elements. As I'm filling each of those shells, I'm being careful to subtract 6 electrons. And once all of those shells are completely filled, I'm left with 0 electrons total. When I check that central atom, sulfur has 8 valence electrons, so it's good. I just need to make sure to put the brackets around the Lewis structure with the charge in the upper right-hand corner. There's a total of 12 non-bonding pairs, 4 bonding pairs. 12 plus 4 gives me 16, times 2 gives me 32. It matches how many valence electrons I needed in the Lewis structure. I'm going to start off by doing the inventory. There's bromine and oxygen. There's 1 bromine, there's 3 oxygens. Each bromine contributes 7 valence electrons, whereas each oxygen contributes 6. I multiply across and add to get a total of 25. Bromate is a polyatomic ion, so I have to factor in its charge to the inventory. I'm going to do the opposite of whatever the charge is. So since bromate's charge is -1, I'm going to add 1 to the inventory to give me a total of 26. Bromine is the central atom. I place the 3 oxygens around bromine. I connect each oxygen to bromine with a single bond. That uses up 6 valence electrons, so now I have 20 left over at this point. I then fill the shells of the outer elements. As I'm filling those outer shells, I'm subtracting. And once I filled all of the oxygen's shells, I have a total of 2 electrons left over. I'm going to place those 2 remaining electrons onto the central atom as a non-bonding pair, and now I've reached 0. When I check my central atom, bromine, it has a total of 8 valence electrons, so it's following the octet rule, so I stop. I just need to place brackets around it with the -1 charge in that upper right-hand corner. There's a total of 10 non-bonding pairs, 3 bonding pairs. 10 plus 3 gives me 13, times 2 gives me 26. That matches how many valence electrons I needed in the Lewis structure. My first step is going to be to determine the total number of valence electrons. I have phosphorus and oxygen. There's 1 phosphorus, there's 4 oxygens. Each phosphorus contributes 5 valence electrons, whereas each oxygen contributes 6. I multiply across and add to get a total of 29. Since it's a polyatomic ion, phosphate's charge is -3. I need to factor in that charge to the inventory. I'm going to do the opposite of whatever the charge is, so I'm going to add 3 to give me a total of 32 valence electrons. I'm going to identify that phosphorus is the central atom. I place the 4 oxygens around it. I connect each oxygen to the central atom with a single covalent bond. That uses up 8 of my valence electrons. Now I'm going to go through and fill the shells of the outer elements. As I'm doing that, I'm subtracting and I'm being careful with the inventory to know how many electrons I have left over. Once I've filled all of those outer shells, I have 0 electrons left over at this point. When I check the central atom, phosphorus has 8 valence electrons. It's following the octet rule, so I stop. I just need to place brackets around it since it's a polyatomic ion with the charge in that upper right-hand corner. There's 12 non-bonding pairs, there's 4 bonding pairs. 12 plus 4 gives me 16, times 2 gives me 32. It matches how many valence electrons I needed in this Lewis structure.